right, welcome to this presentation. The conference paper title is Web3-based role and token data access, the case of building material passport. My name is Hunhevicz and I present on behalf of the other co-authors, of course. So the built environment is becoming more digital and more data is being generated that can be useful in the transition to a circular economy. For example, material passports can assist maintenance or repairs to prolong the lifetime of a building or built asset, or also help to know what materials or components can be reused at the end of life cycle. Having said that, there are potential problems the way we access and store data nowadays. So for that, we need to quickly see how this works technically. For example, you have most of the time you have some data storage, which often is using a cloud service, so it's operated by some company or third party. The cloud is just someone else's computer. And then you have some sort of authentication mechanism, mostly some server that sees whether the login credentials like an email or password match the ones stored on the backend server, and then further directs the call to the data. So why do I say there are potential problems? So the problems, even though this solution works very well and it's very handy to use, very frictionless, these services can have problems over long time periods. For example, when you have a building over decades operated with a lot of stakeholders involved, they store probably data in different locations. So you need to collect the data at one point, but even if you do have a common data environment, you could have password loss, the stakeholders could vanish, the servers could go out of operation, and there is a non-zero chance that at the end of the life cycle the data is not there anymore. So to mitigate this challenge and help data stay accessible over time, we wanted to look into the new promise of Web3 for access methods that match these long time periods and can be more robust. And to understand this question, we need to know what is Web3. There is one definition where it says Web3 promises a decentralized internet where users control their own data, identity, and destiny. That's from the Web3 Foundation. There was also this tweet which I liked. I don't know if that's the original tweet. There were multiple ones that look the same. But basically what it says is nowadays we have Web2 read-write, so we can modify our data and read it. But with Web3, the promise is that we can also keep ownership and not hand it off to a third party. Don't confuse it with Web 3.0, which is more referred to as the semantic web, which ensures machine readability. So it's more about ownership and control of data. So basically the technologies that allow to do this are blockchain or zero knowledge trust protocols, as the Web3 Foundation calls them, or decentralized data storage protocols. So when we compare this with the way it works nowadays, it's actually similar that you just exchange certain components. The data storage is this decentralized storage networks that give you a unique content address, an identifier that you can use to find your data in this decentralized storage network. And the access is managed by a blockchain smart contract. So the smart contracts then check whether or not the users hold the right private keys in their wallet to access the data. And if you compare this, the goal is that you kind of mitigate some of the failure points and you create a more robust system that still allows to access the data even though people lose their private keys, they vanish, or servers go out of business. The key here is you could also create similar systems with Web 2. However, the important aspect is that the trust stays with the technology. So the assumption is that the technology is robust and exists until the end of the life cycle of the building, and you can recover these access rights and access to the data. instead of being dependent on some third party that gives you access. So we wanted to check whether this is actually feasible nowadays to implement, and we did this with two access mechanisms. So one we called role-based access logic. So basically the idea is that you give a smart contract, you map in a smart contract which address has access to a certain unique identifier that points to the data. And this is actually very similar how it works nowadays. You have fine-grained access control on an address level, and access can also be removed by removing the address from the smart contract. And however, it's not so scalable as authorized users must add and remove these addresses. So of course, you can then think about mechanism how this could be also decentralized in a way, but that's one of the challenges with this. So the technology stack that we used is that we have a blockchain in the middle, which all the nodes expose that you can access, and the smart contracts here living on the blockchain. Then the data storage on the left, we used Gaia, which is one storage protocol that works well with the Stacks blockchain. And then you have the users here that control in the wallets their private keys and access through a decentralized application for that you have a user interface and interact with the smart contracts. So basically you upload the data, you can register one address, for example wallet B, and if wallet B wants to access the data, that's the check is in the smart contract and you get access if the role's there. So that you can see this in action, I show you the prototype. I think then it becomes a bit more clear. So you can log in with your wallet to this decentralized application. So this is your address. Then you upload data or a file. In this case, it's just an example of a material passport. And then you allow sharing with the decentralized application. So the decentralized application can now manage access rights, and you can define in the sharing control page how these access rights should be given away. So for address-based, you register another address, you execute the transactions, and then you see the smart contract, the function gets executed, and once the transaction is confirmed, the smart contract knows now this address has access to that data. And if you log out and log in with the new account that has access now, you actually are able to read the file and access the file. And if you log in with an account that, because it's a decentralized application, everyone can log in that has an address, but if it's not the address with the right role, you don't get access to the data. So that's how it works. And the second access mechanism that we implemented is token-based. And to understand what a token is, it's basically an asset on the blockchain that represents some sort of value, and you can send around in the network. And there are two main token types. One is fungible, meaning every token is the same, and you can think of it as a currency, for example. It's similar as the euro. Doesn't matter which coin you have, it's all the same. Or non-fungible, which means every token is unique. So you can think of a good analogy is an art piece. So the Mona Lisa, there is only one original, and you will always be able to know which one is the original, even though there is a lot of copies, right? So this would be the non-fungible token that you can send around. So we use this then also in a similar way, but instead of checking whether the address holds the right role, the smart contract checks whether the address holds the right token. And with that, you make access rights portable. So you can send the tokens around, and once the token is held by another address, this address has then access to the data. And you can also prove access without signing actually a transaction, because these tokens are visible. You know who holds which token. The downside might be that it's more difficult to control access at the individual address level. So the whole mechanisms work the same. We have two smart contracts now, one that actually mints the token. A token is just another smart contract on the blockchain. And you have the smart contract that manages the token access logic. And then you mint the token, you send it to the new address, and then when the other address wants to access the data, the smart contract checks whether the token is held by the right address. All right. So in a way, it works very similar. So you have sharing control for token-based access, where you need to mint the token. Once the transaction succeeded, you can send the token to another address, and once this address then holds the token, you can actually, similar as before, log in with the new address that holds the token, and you will have access to the file. So on the front end, you don't really see a difference. It's more how to distribute the access rights. All right. To conclude, we managed to build this exemplary Web3 prototype that shows that it's possible to create these access mechanisms. Nevertheless, there is still a lot of technical challenges that remain. These both blockchain and decentralized data storage protocols are rather young technologies, and there is not so much documentation. All these mechanisms are not just out of the box, so you need to come up with them yourself. And the degree of decentralization and robustness promised by the technology is actually only there if you implement it the right way. So just using the technologies doesn't better the situation, but if you design it the right way, there is actually, I think, it's a very promising potential way forward to manage data access rights over long lifetimes in the built environment. And we found especially token-based access mechanisms very interesting, since it provides a completely new dynamic how you can manage access rights and actually make access rights portable. So just sending a token to someone else gives them access to the data. All this code and the prototype, it's available online on our GitHub. So if you want to have access to it, feel free to scan the code, or I think it's also in the paper, or just approach me. Thank you for your attention, and happy to answer questions if you have any.